Today's topic is limit, and here you can see all the 9 properties of limit from 1 to 9. You can feel free to pause the video and verify all the 9 properties. Here we have limit of x squared plus 2 as x approaches 2. Here you can solve by direct substitution, where you have 2 squared plus 2. You replace x by 2. You obtain 4 plus 2 equals to 6. Here we can apply property 9, which says that it is same as the cube root of the limit as x approaches 3 of 3x squared. You replace x by 3. You have the cube root of 3 into 3 squared, which is same as the cube root of 27, which is same as 27 to the power 1/3, which is same as 3 times 3 times 3 to the power 1/3, which is same as 3 cubed times 1/3 equals to 3. In this case, if you solve by direct substitution, we have 2 squared minus 4 all over 2 minus 2 give us 0 over 0. Here is indeterminate. Here we see that we can replace the top by the limit as x approaches 2 of x minus 2 and x plus 2, x minus 2, because x squared minus 4 is same as x squared minus 2 squared. Difference of two squares in factorization is x minus 2 and x plus 2. By doing that, x minus 2 cancels. You are left with the limit as x approaches 2 of x plus 2. Substituting x by 2, we have 2 plus 2 equals to 4. Here, if we solve directly by substituting x equals to 3, we obtain 3 cubed minus 27 all over 3 minus 3 equals to 27 minus 27 all over 3 minus 3, 0 over 0, indeterminate. But we can factorize x cubed minus 3 cubed into x minus 3 into x squared plus 3x plus 9, which is same as the limit as x approaches 3 of x minus 3 into x squared plus 3x plus 9 all over x minus 3. This cancels this. We are left with the limit as x approaches 3 of x squared plus 3x plus 9. Substituting, we obtain 3 squared plus 3 into 3 plus 9, which is equals to 27. Here, if we solve directly by substitution, we obtain 1 all over 4 minus 1 all over 4 all over 4 minus 4, 0 over 0, indeterminate. Here, you take 4 and x, 4x, 1 all over x minus 1 all over 4 all over x minus 4 and 4x down also. The limit as x approaches 4. You obtain 4x times x. The x cancels for this. You are left with 4 minus 4x times 1/4 gives x all over 4x into x minus 4. You are left with the limit as x approaches 4 of minus into x minus 4, factorize minus up, you have 4x into x minus 4. Here you can see that x minus 4 cancels. You are left with the limit as x approaches 4 of minus 1 all over 4x, which is same as 1 all over 16. Here in this example, solve directly by substituting x. We obtain root 4 minus 2 all over 4 minus 4 equals to 0 over 0, indeterminate. But here you can multiply top and bottom by the conjugate of the numerator, which is same as the limit as x approaches 4 of square root of x minus 2 all over x minus 4. The conjugate of root x minus 2 is simply root of x plus 2, top and bottom, root x plus 2, which will give us the limit as x approaches 4, root x times root x, simply x, plus 2 root x, minus 2 times root x, minus 2 root x, minus 2 times positive 2 gives us minus 4 all over, unchange the denominator, x minus 4 root x plus 2. Here you see that this value and this cancels. You continue as limit as x approaches 4 of x minus 4 all over x minus 4 into root x plus 2, which is same as the limit as x approaches 4 of 1 all over root x plus 2, because this value cancels this. Substituting x, you obtain 1 all over root 4 plus 2 equals to 1 all over 4. Here you have the limit as x goes to infinity of 1 over x. Infinity means very large values. For example, if you have 1 all over 100 is same as 0.01, 1 all over 1000 is same as 0.001. So that as x goes bigger, this value tends to 0. Therefore, the limit as x tends to a very large number of 1 all over a large number is simply 0. Here we have 8x plus 2 all over 2x minus 5 as x goes to infinity. Here if you replace x by 100, for example, you obtain 802 up and 195 down. This value is approximately 4. But we can solve it by doing 8x plus 2 multiplying by 1 all over x, because the highest power of x is degree 1 all over 2x minus 5 and 1 all over x. The limit as x goes to infinity, we obtain the limit as x goes to infinity of 8 plus 1 plus 2 all over x and 2 minus 5 all over x. And if you apply property of limit, which is same as the limit as x approaches infinity of 8 plus the limit as x approaches infinity of 2 all over x all over the limit as x approaches to 2 minus the limit as x approaches 5 all over x. This limit tends to 0 and this limit tends to 0 because when x becomes large, this limit tends to 0. But limit of a constant is simply 8 all over 2, approximately 4. Therefore, as x tends to infinity, this function tends to 4. Here we have the highest power of x to be 2. Therefore, we can take the limit as x goes to infinity of 3x squared minus x multiplied by 1 all over x squared, 5x minus x squared plus 2 multiplied by 1 all over x squared, which is same as the limit as x goes to infinity of 3 minus 1 all over x all over 5 all over x minus 1 plus 2 all over x squared. Taking individual limit, this limit as x goes to infinity tends to 0, tends to 0, tends to 0. You are left with 3 all over minus 1, which is minus 3. And the simplest way to solve such question, when you identify the highest power of x in the numerator and denominator, which is 3 and minus 1, which can give you minus 3 directly without solving. Here is solving limit graphically. You are asked to find the limit of f of x of the function as x approaches minus 3 to the left side. This is minus 3 to the left side. Talking about this function to the left, you obtain 2. The limit of f of x as x approaches minus 3 to the right side, we are talking about this, where we can see it is minus 2. Now we are asked the limit of f of x as x approaches 3. Since the left side is not equals to the right side, the limit of f of x as x tends to approaches 3 does not exist. Here we are asked to identify the limit of f of x as x approaches minus 2. We identify first minus 2. F of x, the limit as approaches minus 2 to the left side, we obtain minus 1. The limit as approaches f of x to the right side, we obtain the same minus 1. Since the left side and the right side, both of them equals to minus 1, therefore the limit as f of x approaches minus 2 is equals to negative 1. And f of minus 2, we go to the point where we meet this closed circle, extrapolate, you obtain 3. Therefore f of minus 2 is 3. Here we are given a function and we are asked to find the limit as x approaches 1. We cannot go directly, we need to find the left side limit and the right side limit as approaches 1 from the left side and 1 from the right side. Therefore, limit as x approaches 1 left side, we see that the value is found in this portion, which is 5 into 1 plus 3 equals to 8. and the limit as x approaches 1 from the right side more than 1, it is found in this portion, which is 1 squared plus 4 equals to 5. You see that left side is not equals to right side. Therefore, the limit of f of x as x approaches 1 does not exist. Here we are asked to find the limit of f of x as x approaches 3 to the left side. We go directly to this one because it is less than 3. You can go as 3 squared plus 4 equals to 13. Here, if we solve directly by substituting x, we are going to obtain sine 4 into 0 all over 3 into 0, which is 0 over 0 indeterminate. But we can simplify sine 4x over 3x into sine 4x all over 3x times 4 all over 4 because of this 4. Here we can proceed as sine 4x all over, replace this 3 by this 4. We have 4x times 4 all over 3, which is same as the limit as x approaches 0. Knowing that the limit as x approaches 0 of sine x all over x equals to 1, same as the limit as u approaches 0 of sine u all over u is equals to 1. Therefore, let u equals to 4x. We obtain the limit as x approaches 0 of sine u all over u times 4 all over 3. This value leads to 1. It is 1 times 4 all over 3. Answer is 4 all over 3. Therefore, the limit as x approaches 0 of sine 4x all over 3x can simply be 4 over 3. Here is same as tan 5 into 0 all over 3 into 0, which is 0 over 0 indeterminate, but we can simplify it as the limit as x approaches 0 of tan 5x times 1 all over 3x. Knowing that tan 5x is same as sine 5x all over cos 5x times 1 all over 3x, the limit as x approaches 0. We can solve it as sine 5x all over 5x times 1 all over cos 5x times 3 all over 5. Knowing that this 5 cancels this 5, making no difference in the limit. Based on limit product, we have the limit as x approaches 0 of sine 5x all over 5x times the limit as x approaches 0 of 1 all over cos 5x times 5 all over 3. Knowing that the limit as u approaches 0 of sine u all over u is equals to 1, replacing 5x by u, we obtain the limit as u approaches 0 of sine u all over u times the limit as u approaches 0 of 1 all over cos u times 5 all over 3. This limit leaves 1, and replacing 0 into u, we obtain 1, because cos 0 is 1, 1 divided by 1 is 1, we are left with 5 all over 3. Therefore, 1 times 5 over 3 ends as 5 all over 3. Therefore, the limit as x approaches 0 of tan 5x all over 3x is simply 5 all over 3.